So good afternoon, everybody. Thanks for coming to listen to this session. My name is Woolf. I'm the founder and CEO of Coalesce.Info. So when I was a little boy, I always dreamed of an intelligent computer. I thought that language was an expression of intelligence, and if we could teach a computer to understand language, not just the keywords, but actually understand what was going on behind the text and the meaning, to me that would have been a way to build an intelligent computer. So does anybody, I'm sure everybody recognizes the story on the right, Isaac Asimov, but does anybody know the author on the left, Robert Heinlein? Show of hands? Great classic authors, right? From the 50s and 60s. And even back then they had this vision that language, building an AI, both of these stories have a strong AI, artificial intelligent entity, which is a theme behind how people interact with technology in the future. So a little bit of a history. I am originally from South Africa, hence the accent. And I started out studying computer science and math, and I actually recently had an opportunity to go back and check my academic transcript. And I found that when I was 17 years old, I had signed up for Linguistics 101 along with math and computer science, which was a strange choice back then. Right? So I landed up trekking off to the medical campus because most of the people studying linguistics were occupational therapists, OTs. And the ratio was me and 99 young girls who were studying that, so not a bad ratio when you're 18 years old. But essentially, you could see even then, I had this idea that combining computers and language was a way to understand intelligence. Unfortunately, I was 20 years too early. So fast forward to today, my path to the USA went through, after the computer science degree, I studied a degree in finance and business, which got me an entry point through PricewaterhouseCoopers into the USA, in fact, at PwC in Boston. And about 15 years ago, I struck out on my own and I started a company called Vantage Software. And Vantage Software is a company that provides solutions for the alternative investment industry. So our clients in that space are private equity, venture capital, and real estate firms, very much in the domain of finance. Our clients in that space manage over $1 trillion, and we're very much focused on the quantitative analytics, so structured data, looking at numbers, calculating private equity performance, etc. for our clients. But 3 years ago, I had this idea, this crazy idea. I saw what was coming with unstructured data. In fact, today 90% of the content out there is unstructured data. And I thought maybe we could help our clients get beyond just analyzing structured data, but looking at the world of unstructured data. And hence, Coalesce was born. So Coalesce essentially makes AI easy for business. Along the way, we partnered with IBM Watson. You can see we have a strong relationship with them. In fact, they even put me in a TV commercial a couple of years ago, which was a lot of fun. And I also won an award, the AI Global CEO of the Year award a couple of years ago. And the reason for that was we had created a layer of technology which sat on top of Watson and today some other underpinning technologies, which allows the user, a business user, to essentially teach the system to leverage their expertise and automate parts of their job, the parts that they least like, so that they can focus on the deeper analytical side of things, the parts that they're more like. And in fact, we're about to launch on the IBM Cloud for financial services, so look out for an announcement early next year. But you'll see we'll be launching a risk analysis tool there. In Boston, I actually co-moderate a number of meetup groups here in town. I don't know if any of you folks have belonged to any of these groups over here. Show of hands. Wonderful. Thanks for coming. And between these three groups, we have about penetration of about 10,000 people in Boston who are interested in coming to these kind of conferences. So it shows that there's definitely a very strong impetus behind AI and machine learning and understanding big data and analytics. We're also starting a new initiative called an AI think tank around the responsible use of this type of technology, which I'll get to a little bit later in the presentation. So AI today. Quick show of hands, who knows what a neural network is and has used it in their environment? Okay, great. So just a little less than half of the people. I feel as one of the leaders in this type of technology in Boston today, we have a responsibility to demystify this technology. Ultimately, machine learning is really just about a new way of programming. And I think that one of the key components, 3 years ago I started building out this product, Coalesce as it is today, and our team started working on it. But there was still a lot of resistance to this kind of technology. I think what made it very real was January 1st, 2017, it was if somebody had thrown a switch and said, you know what, This technology is here, it's here to stay, it's going to make an impact in people's lives. And I call that the Alexa moment. So Siri's been around since 2010, Watson's been around since 2011, self-driving cars, Google, 2014. But it was when Amazon was able to take a device and put it on your kitchen table, and people could interact with that device and ask questions like, what's the weather going to be like tomorrow? Or what's the GDP of Turkey? That people were like, that's kind of interesting. They could engage that technology in a conversation, and they thought, you know what would be really useful? I'd like to get that at work. So a little bit of a background over here. This is our interpretation of machine learning and AI in the spectrum. So we see, this is the knowledge pyramid. Anybody familiar? Anybody seen this graphic before in a different kind of context? Sure, a few hands. So we divide artificial intelligence into two different components. Firstly, at the bottom there's data and information. That's not necessarily related to artificial intelligence. However, that's definitely the fuel that's driving it. If you look at the main reasons as to why it's so prevalent today, there's the fuel, i.e. the data, and the bandwidth, i.e. the cloud, right? But essentially, the artificial intelligence layer sits on top of that. And we divide that into two parts, machine learning and predictive insights. So knowledge is having a GPS system tell you to turn right at the next intersection. Wisdom is having a GPS system tell you not to turn right at the next intersection because there's a concert later and there's going to be a huge traffic jam in 10 minutes when you get there. Rather overshoot by another off-ramp on the highway and double back, it's going to be faster, right? Knowledge versus wisdom. And we define the technology that we use to help our clients with this kind of information is machine learning and predictive insights. So by machine learning, what I mean somebody who comes into their job and asks the same question every day, and the system can learn using our technology, using some of the underpinnings like Watson and Google TensorFlow and some of the libraries that we use, to essentially teach the system to learn how to differentiate and do their job. And I'll show you some examples of that in a minute. And I believe this is where the state of the art of the technology is being applied in commerce today, especially in financial services, which is our focus today. So having the system learn to do a repetitive task, learn from the use of machine learning, that's that knowledge layer. The wisdom piece is the predictive piece. And that's where it's really interesting, and that's where there's benefits and costs, and we're all really excited, but also somewhat scared about the capabilities of machines being able to do things better than we can, right? The predictive piece would be the analogy of having the system be able to identify patterns that we humans are not able to understand and identify because we just can't put that amount of information in our brains. Realistically, I think it's early days in the adoption of artificial intelligence. We're definitely seeing in the world of knowledge and machine learning our clients saying, yes, absolutely, this is like moving from plowshares to tractors. I'd be only too happy to get out of this workflow and have a computer do some of the repetitive, boring, risky, error-prone type of work. But when it comes to trusting my job to the computer, coming in the morning and saying, I'm going to just believe what the computer tells me is the top things that I need to focus on today. It's still early days. However, the promise is there. And what we're building with our application is an understanding of the world and the capability to do that. So machine learning has the system learn to do the job and rinse and repeat. Predictive insights is the predictive futuristic part of that. And we're working on both today. Realistically, machine learning is where people are getting value. So deep learning and neural networks, hot topic. Everybody's crazy about this. It's a great technology. Frankly, we have a guy on our team who's actually written 25 books on machine learning and AI. He's in his 60s, and he says to me, Greg, this technology's been around since the 1950s. Once again, it's the fuel, data, and the processing power and bandwidth, the cloud, that allows us to enable us to use this technology. But I just wanted to give you a little example. So on the left-hand side over here, you can see a pattern. And can you see from the back there, it's a mixture of red and black dots, right? Essentially, it's a double spiral. And the first, you probably can't see this so clearly, but at the top here, this is a generalized linear model. So this is the typical statistical line of best fit. Can we get a line to essentially go across this pattern and identify some kind of model that understands the nature of this data, right? And obviously it's very poor because we're fitting a line to a shape that's clearly not linear. The second piece is another type of machine learning called distributed random forest. So it's a more advanced piece of technology which is able to better pattern this, but you can see it's still it's like trying to chop up a number of lines and then kind of fit them. And the last piece is the magic, right? Deep learning. So essentially, when I've colored it in yellow, just for your benefits, you can see I've traced through the pattern. But through a number of different layers and a number of different matrices of math, the system is able to, on a iterative process, identify an underlying equation which maps that data set, which is the deep learning sees. And I think you can see pretty clearly it looks exactly like a spiral, so that's pretty impressive. So, back to language, right? There's a lot of news and noise on the web about machine learning and language and natural language processing. One thing that was kind of a little under the radar, but I feel was really interesting was late last year, Google came out with a new mechanism for doing natural language translation. So Google Translate obviously used widely spread into many different circumstances, but it initially was based on kind of a dictionary approach of compare one language to another. The problem is there's so many pairs, right? There's so many different combinations of languages in the world. So they took a different approach and they used some graph technology and some very sophisticated machine learning, and they let the system figure out itself. So what you can see here, and I know the resolution is not great at the back, but essentially there's 3 colors for 3 different languages: English, Korean, and Japanese. Very different languages. And they let the machine use this type of deep learning capabilities to translate a sentence. So the sentence is, the stratosphere extends from about 10 kilometers to 50 kilometers in altitude. Firstly, who knows what a kilometer is? I grew up with them, so I'm more used to them. But it's a complicated sentence, right? I mean, this is not, the cat sat on the map. This is a very sophisticated piece of information. And what's interesting about that is when you look at the detail over here, the system has gone and it's created what they call interlingua. It's its own kind of derivative language. It's a mathematical construct of the words in this sentence represented in a mathematical fashion. And you can see that the pattern of the words in the context of how they're being used. This is not a translation to say the word stratosphere in English, Japanese, and Korean is da 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 and tie it together. This is an understanding of what that concept means, the distance of kilometers, and it's created a graphical representation of the underlying math behind the scenes, and you'll see that there's almost a perfect overlap. And with this methodology, I believe Google was able to translate 100 different languages almost overnight. So this is one of my favorite stories as well, right? This is the potential negative side of AI. So there's an online game called Elite. So anybody ever heard of those massive online games where they have thousands of people creating accounts and they spend thousands of dollars and tens of thousands of hours a year building an online persona in some kind of fantasy domain, whether it's futuristic or historical. Anybody familiar with those kind of things? Right, I see a few gamers nodding in the audience there, not willing to raise their hands, I get it. So if you play Elite, you might have noticed that, and I haven't, but I'd really be cool. I think it would be kind of a fun thing to try. So last year they had a little problem at Elite. One of the skills that the game maker brings to the table is they allow the characters in the game, the users of the game, to create these online persona, these characters. They give them a skill called crafting, and it allows a person to personalize their character, add new skills, get more engaged with it, ultimately for the point of spending more time online. So the creators of the game thought, well, hold on a second, this isn't fair. We're giving the humans, the users, the ability to craft their own weapons, armor, food, whatever they need. Why don't we give those same skills to the bad guys, the AI monsters that live inside the game? Well, it turned out the results were a little bit scary. So back to the whole Skynet Terminator. What happened was the AI was got nothing to do but all day long but sit around and think about combinations and permutations, right, of how it would use stuff in the game with the sole objective of killing the humans. Came up with a bunch of creative weapons that were so far in advance of the humans, right? Same set of rules and regulations and same materials. They didn't have anything different than the same capabilities that we had. But they came up with a set of weapons that was so powerful that they completely decimated the humans. So, I mean, the world of Terminator is far away, but I do think that this is a very powerful technology and we should be very careful how we use it. So how does this apply to financial services, right? So we started out in the space of investment research, but I'll show you a few examples in a second. So IDC gave us permission to use this slide over here. This is the digital universe, and what they're showing is the growth of information. And this is in, I don't even know, petagigabyte, some zettabytes possibly, but a very significant number of data points that are growing, and you can see this growth is exponential, right? Especially in the world of unstructured data. So structured data is the type of data that you can easily find in some kind of database, some record online. The unstructured data is language, images, etc. And that, as you can see, is growing ridiculously. Similarly, McKinsey recently came out with a report where they categorized a heat map of where is this AI type technology most likely to be deployed. And the top industry is going to be developed and deployed. In other words, where are companies spending money on this? So the top industry is high-tech and telecommunications, essentially the manufacturers of this technology. Companies like us and smaller companies like Google and Baidu going out and building this great technology. Similarly, interestingly enough, automotive and assembly was the second largest industry, and that makes sense, right? Firstly, automotive uses a lot of mechanical manufacturing robots, right? And then the world of automation, self-driving cars essentially, autonomous vehicles. But third is financial services. And this makes a lot of sense, right? Because the amount of data that there is available in financial services is so prodigious that we really need some kind of technologies to help us with that. So I'm going to give you a few examples of what we've been doing with our clients. As I said before, my previous company started out with investment research, and we helped our clients find better opportunities. So we have a client who looks at about 1,000 companies, 15,000 news articles a month. And their analysts have taught the system, using our proprietary technology that overlays these other technology tools, to personalize the way that they teach the system to read the news articles on a daily basis and identify companies that are exhibiting positive signals, pre-expansion signals that they call them, of potential investments that are interesting to them. So that's where we started out, because we've got 15 years of experience in that space. And once we deployed that solution, one of our clients came to us and they said, Greg, this is interesting. You can teach the system to look for good signals. Could you teach the system to look for bad signals? At which point we said, well, wait a second, we don't really know what you mean. Why don't you teach the system and have your analysts teach the system to look for bad signals? So we moved into the world of risk and compliance. So there's a client which is invested in, through other managers and their own direct investments, they're invested in about 10,000 companies at any point in time. And they have a team of 20 analysts going out and scanning for bad news around these companies on a daily basis. And it's not just about the investments that they're making, they also use this for diligence, for looking at potential future investments that they're looking at making. And their problem was, right now, who can go and Google 10,000 companies? You could have hundreds of people and you still wouldn't get to 10,000 companies on a frequent basis. So they essentially were using sample testing. They were saying, we know what are risky industries, mining, for instance, energy, places where there could be environmental remediation problems. We know where are risky regions in the world where there's political instability, or maybe there isn't such of a sophisticated financial system in place. So essentially they were looking at about 1,000 companies a quarter. So over a year, maybe 40 to 45% of their portfolio, which is obviously pretty risky. So they taught our system to look for the kind of signals, and there's about 10 different things that they've taught our system to look for on a daily basis. And essentially we're now profiling 10,000 companies a week. So we may not get everything, but the chance of us missing something and getting it the next week is a lot better than their current process. So that's in the risk and compliance. Similarly, we had another client who said to us, we see what you're doing getting content from outside and bringing that in and analyzing that, but we have a big problem with emails. This is internal content. Can you teach your system to read our emails? We're a bank. This company is a bank. And they get 40,000 emails a month. And they need to dispose, the disposition of each of those emails. Their responsibility to their banking customers, and they need to touch every one of those emails. So what we did with them, and what we're doing with them, is we're teaching the system to essentially identify the 5 or 6 main categorizations of disposition that they're looking for. For instance, a lot of the queries that come in are, I lost my password, how do I get online, I can't get online. Humans saying the same thing many different ways, and that's where the natural language processing machine learning is very helpful. So we're teaching the system to identify those kind of queries versus, I have a query about my bill. I need to know what the fee was that you charged me last month. Versus, I'm very happy with my mortgage, do you guys do auto loans? Right? So there's upside as well as downside. So we're teaching the system, or rather their group of 300 customer service reps are teaching the system, and actually it's not the entire group, there's a core group of the best customer service reps. So side note, open parens, This technology allows you to institutionalize best practices and embed that into the software that it learns, and then you can roll that out across the broader user base, close parents. So we're teaching the system to essentially dispose of those type of queries and cut that down to a manageable few that really need to be touched and spoken to by a customer service rep. And as the next phase, once we've proven to them with a reliable confidence that our system is capable of identifying the right type of communications inbound from their banking customers, we're able to then apply a completely automated loop. Where, let's say, for instance, we're very confident that somebody says, I lost my password, I can't get online. We can then pass that query. We know who the customer is from the email. We know that we can get their account number from a database, all programmatically, and we can pass a service request to their internal systems to automatically process that password change. And the beauty is, this is very transportable from one customer to the next, because remember, in our model, the users are teaching the system the domain expertise. So we could take it from financial services to biotech tomorrow, depending on what the customer service needs are in a different industry. Possibly the queries are around, where are my clinical trials? And how do I speak to a doctor? Yeah, can you recommend a doctor about certain expertise? So streamlining operations, while we're focusing internally, we have another customer who said to us, Greg, we get 6,000 pieces of paper a month. Once again, it's an investment client. We get 6,000 statements from our underlying managers every month. And we have a team of 25 people who are pulling these PDF documents out of their emails, saving them, and aggregating the results for aggregated client reporting. So we're doing two things there. The first thing is we're reading all the emails, because all those statements come into an email inbox, which is meant for a bunch of things. So we're identifying which of these emails specifically are around an account statement. We're taking the email identifying which is the correct email. We're taking the PDF document out of the email, saving it onto the hard drive in the network, opening it up, identifying what is the product, what is the account, who's the investor, what is the date, what is the ending value, and then pushing that number into a database that they can then aggregate and do aggregated reporting for their customers. Now the critical thing to all of this is confidence, right? Confidence from the users and confidence from the system. As I said before, machine learning is something that people are prepared to trust if they can get the confidence that it works. Nobody's really ready to kind of stake their job on the predictive capabilities yet, but I think we're going to get there. So when we do this process, not only do we tell let's say we take the emails, not only do we tell the customer, these are the emails that we were able to filter and identify as password queries, but we're also able to tell the customer which ones we think, we're only about 75% sure that we got this right. So being able to profile 50% of the emails and automate that is great, but we've got to tell the customer which 50. So that's really important, obviously. Okay. So another use case, the last use case, is marketing and fundraising. So obviously this is a great tool for prospecting. Our clients use it for prospecting underlying investments, but they can also use it for prospecting and finding their own customers and clients. And this is an interesting one. We did this for some wealth managers who are out there looking for clients who meet a certain profile. But we recently landed a project with a university, which is a little bit outside of our domain, but it shows that this capability is mainstream. And they have an office called a development office, which has got nothing to do with software. It's all about getting money in from charities and from people who want to donate for programs at the university. And the traditional way of doing this process is they have a development office, which is a very sophisticated group of people who understand their alumni base, and they can send out solicitations to their alumni and students, but mostly they're past alumni asking for money for certain programs. The big problem is this university is building a theater for performance art. The problem is performance arts, if they send out an email to everybody who studied a BA, they may not necessarily have the means to be a good donor, firstly. And secondly, they may not have an interest in the program. And yet there may be lots of alum who have a strong interest in the program. In fact, on a side note, I recently met with the the portfolio manager of a very large mutual fund locally. And we had a great conversation for about 10 minutes about AI. And then we had another conversation for about 45 minutes about a charity that he set up to help disadvantaged kids. So often people very successful in life have gravitated away from the area that they study and may be very interested in the kinds of programs that are useful to this type of university development office. So what we did was they gave us 1,000 people initially, of alumni that they hadn't heard from for 10 years. And they said, can you go profile these people and see what their interests are? Because we don't really know. We haven't heard from them for a long time, and we don't really know what they're up to. But we think these are good likely prospects. And our system came back with about a 4 to 5% rate, so about 40 to 50 people For example, one person was a woman who had married a hedge fund manager, moved down to New York City. He sold his company for $1 billion, and they'd made the single largest donation to a museum and an art facility down in New York City. At which point the university said, why didn't we know about that? So profiling people and having, but who could go out and do 10,000 Google searches or 100,000 Google searches across that wide database and have the system understand what it was getting back? So it seems like that's a great space to help people as well. So just a couple of numbers. People always like to see some metrics just to give you some ideas. Earnings transcript, narrative, natural language information around companies. Typically, you take the 4,000 most highly traded companies. There's about 16,000 earnings transcripts a year because they're quarterly. And that turns into about 120 million words to decipher. And a human would take 5.7 years to process all that information. Our system would take 25 hours to process all that information. That's an entire year's worth of analysis down to 1 day. And then similarly, when you look at the compliance analysis, what we're able to do is instead of profiling 1,000 companies per quarter, but by profiling 10,000 companies a week, we're able to reduce the cost of that profiling from $20 by humans down to 12 cents, which is obviously a significant saving and benefit for the customer. Okay, almost done. So the future is looking rosy, mostly. Right? This is a great space, very interesting capabilities. I'll end off with a couple of book recommendations and a little bit of a warning. The first book is called The Turing Test, which is a story about a rogue AI that takes over the utility infrastructure and obviously causes tons of havoc. And the second story is called The Fear Index, which is a story that actually got off Bloomberg, which is a great read. And it's about a rogue AI that takes over a hedge fund and essentially creates a bunch of global instability. And I mean, these are fun to read, but I always see sci-fi as a kind of prediction of the future. And when it comes to the world of AI, and the reason why we've set up this think tank and we're starting to pull people together to create a set of guidelines and a framework for the safe and confident implementation of this kind of technology. So I believe that there are 3 potential risks with the technology. The first one is lack of transparency. So back in the old days, when we were just coding, hard coding, you could have 10,000 or 100,000 or 1 million lines of code, but we could, But we had a process called code review, where one developer would go and read another developer's code and make sure that they understood, for compliance purposes and just for good coding techniques, standards and everything, whether it actually worked. And it was really clear. The line of code says does what it says or it doesn't, right? These days, when you look at technologies like that neural network, essentially that technology it's a massive matrix. Think about a 3D spreadsheet, where instead of having with millions of columns and millions of rows, and it's 50 or 100 or thousands of spreadsheets deep. It's this massive cube of data, which we humans are not able to understand. So the lack of transparency in these models is a concern because we don't really get them. We can't understand them. And they're not always exactly reproducible. One of the methodologies for building these kind of algorithms is, for instance, a genetic algorithm, which uses a random seed, uses a random starting point. So you could take the exact same input data and throw it into these models and come up with a close but slightly different outcome. So I believe that lack of transparency into this more advanced technology is a potential risk. The second thing is dependence. Okay, as we see AI, and I'm the biggest proponent of putting AI into systems and into our daily lives, but as we see AI become more heavily used, there's the risk that we become overly dependent. Do I think the robots are going to come out, or the AI is going to create robots and come out with machine guns and start shooting us all? Really, I'm not less worried about that. But I am worried about some kind of machine learning algorithm which could make poor decisions on our behalf, like for instance shutting down all the MRI systems in Boston for an hour, or changing all the traffic light to green for 20 seconds. Right? Think of the havoc of becoming dependent on these systems, what that could create. And then the third piece is infiltration. Right? So I think in the future, this technology is so powerful, and as we saw from those economics earlier, the ability to deliver capabilities, I think the winners of economic and business and corporate and even potential political battles will be driven by who has the strongest and the best AI. And of course, the bad guys are after this as well. And the ability to infiltrate our systems and sway them and modify them is a real risk. And cybersecurity and that whole mechanism is obviously really important. So those 3 things I think we need to safeguard against. And by putting in a process and guidelines, working with folks we're working with very senior people in healthcare and financial services and academia who've been around this for a long time and have implemented new kinds of technology and see a safe way to implement this so that everybody can get a confidence level around this. I believe that's going to be the way forward. Thank you very much. Appreciate your time.